Hello and welcome to the next video. We're continuing on with showing that triangles are congruent. Today we're going to be focusing in on showing how they're congruent by two more theorems. The last one was side, side, side. This one we're going to go with SAS and HL. So before we get into that though, there's one key piece of information to understand, and that's when we're talking about something called the included angle. Because the next one is going to be having an angle in between two sides, we need to make sure we're referencing the correct angle. So if I go through and I list off AB and I list off AC as two of our sides, the included angle is essentially the vertex that exists. So as you can see on the right hand side, angle A is going to be the included angle. So it's the angle that's between the two sides. If you marked it out here or you marked it out here, then you're doing it incorrectly. So that is to assist us with our next theorem here, which is the side angle side congruence postulate. Again, we abbreviate that as SAS. Okay, so this says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So for example here, if the side segments AB and RS are congruent, so we're talking about this side compared to this side, and then we have the angle ABC and angle RST, so this angle is congruent to this one. Let's go ahead and mark that on our diagram. And then finally, segment BC is congruent to segment ST, so BC congruent to ST like that. Then we can go ahead and say those two triangles are congruent. So let me show you why it doesn't work if we don't do the included angle. Okay, so again, it's side angle side, so side angle side, one right after the other there. So let's show you the two different cases if it was the other angle. So let's say this was our original triangle here, and this is a case where we have side-side angle. As you can see, angle A is not between the two sides. Between the two sides would be, right there. That would be the included angle, but we in fact don't have that. And so I want to show you why that happens. So if we only know the information that's on the screen right now, excuse me, and I know nothing else about anything else, meaning the other side or even the other two angles, then what I can actually do is draw a second triangle with the same exact information, and these guys are not going to be congruent to each other. So even though we have ourselves an angle, and then the two sides here and here are congruent, what can happen is angle B, we can swing it outwards, and we create ourselves a second type of triangle, even though we have the side-side angle deal. Okay, so you see how those two lengths there are not equal to each other. So what I want to point out to you, if you write down side-side angle, or the reverse of that, and I'm sure you can see what that says. If you wrote it backwards, then you have done something wrong. So if you ever write down a curse word, you know you've done something wrong. That does not happen. Okay? Alright, moving on to the next one, we have to understand the right triangle and the different pieces to a right triangle. So there, with that, we have ourselves the right angle. The two sides that make up that right angle, that 90 degrees, those are called the legs. And then directly across from it is our hypotenuse. So it's really important for you to understand what pieces are hypotenuse and which ones not for our next one, which is the hypotenuse leg congruence theorem. So we abbreviate this as HL, but what it says is that if we have the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second triangle, then the triangles are going to be congruent to each other. The issue with these is that students tend to see this and then they write down the angle side. So you have to be really aware of what's going on. The right angle there is telling us that we have a right triangle. So whenever you see a right triangle, your first instincts should always be hypotenuse leg. That does not mean it's always going to be hypotenuse leg, but that's going to be your first instinct, okay? Or should be your first instinct, okay? All right, let's move on. As you know, we are doing lots and lots of proofs in this unit, as we mentioned before, so let's go ahead and do a couple of those. So taking a look at the diagram I have here, remember we always start off with our givens, so segment BC is congruent to DA, and we also know that the two pieces are parallel to each other. So from here, what we need to figure out is what else is going to be congruent to each other. Well, the reason that we have this parallel lines there has to be for some type of reason. And so anytime you kind of see that, you have to think, well, I've got two lines that are parallel to each other, so here, and I'm getting cut by a transversal. And so we can actually tell a lot from this. Specifically, we can tell that this angle is congruent to this angle. So please be careful that make sure the angle you're identifying is touching one of the two parallel lines opposed to using this angle or this angle here. Those guys are not necessarily congruent unless A, B, and DC were parallel to each other. Okay? So my next statement is going to be that angle DAC, so this angle right here, is congruent to angle BCA, so this one up here that we just identified, and the reason is the alternate interior angles theorem. So that's something we learned way back in Unit 2. So it is going to come back and you're going to see it quite a bit. So just be aware of that, okay? All right, the next thing here, and this is also going to happen almost all the time, not all the time, but very often, is if we're sharing a side, okay? So the two triangles are sharing this side here, so we have to bring that into our proof. And so we do that by listing that it's congruent to itself, okay? AC, this first one is talking about the triangle on the top left, okay? Triangle ABC. But this second one here is talking about the piece to triangle ADC. So even though it looks like it's saying the exact same thing and it kind of seems redundant, those two pieces actually represent two pieces of two different triangles. However, they are actually the same thing, and we know that by the reflexive property of congruence. So as you can go through here, kind of analyzing what I have, well, this is a side, this is an angle, and this is the side. And so we want to just make sure that it is in fact in the correct order, that the angle is between those two sides. So we have side, angle, side, so we know that we're good. So the two triangles are going to be congruent, and now our reasoning would be side, angle, side. So right now, side, 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 angle, side, and hypotenuse, leg are all valid reasons as to why we can, as a reason is one of our proofs in showing that two triangles are congruent. Okay, moving on to our second one, and this will be the last one for this video. So we have some key pieces here. We know that the side lengths WY and XZ are congruent. We know that those two pieces are perpendicular. Okay, so again, we've got WY, which is this piece here, okay, and we have XZ, which is this piece here. Those guys are congruent to each other, and then the second piece there is also given, tells us that this is a right angle and that this is a right angle. And so right now we can see, all right, I got myself a right triangle. And so since I have a right triangle, somehow I want to bring in hypotenuse leg. So I have to show one of the legs are going to be congruent to each other. And in fact, it's just like that previous one. You see how they're kind of laying on top of each other just like that? That's exactly what we're going to use. ZY is congruent to itself. Now remember, even though it seems kind of redundant, each of the ZYs come from a different triangle. And they are on top of each other, so that's reflexive property of congruence. So going through, I know that this is telling me it's a right triangle. This is the hypotenuse. This is one of the legs. So the triangles are going to be congruent to each other, and we're doing that by hypotenuse leg. Okay. Our last example here, you are making a canvas sign to hang on the triangular wall over the door to the barn shown in the picture. You think you can use two identical triangular sheets of canvas. You know that RP is perpendicular to QS, and segment PQ is congruent to segment PS. What postulate or theorem can you use to conclude that triangle PQR is congruent to triangle PSR? Okay, so taking a look at what we have, it's already marked in the diagram. I can see right here that we know that the two pieces are perpendicular to each other. That's what the upside down T represents, perpendicular. And then the two individual pieces, QP and PS, they are congruent to each other as well. So then you kind of want to think to yourself, well, is anything else congruent to us? So we know PQ and PS, and by the reflexive property, we can identify the one that's being shared right here, that RP is congruent to itself. And so we want to think, well, is that enough information? And so what I want to do is see, well, is this hypotenuse leg? Because it's a right triangle. Naturally, we want to go to saying hypotenuse leg. So identifying this, I see that the things are perpendicular, so I see the right angles, which is what I just discussed. So if I go through, I see, okay, well, PQ and PS, those guys are legs, but RP and RP, that's another leg. So this might not actually be something valid that we can use. So instead, I notice that that's a side, and then that's the side, and then that right angle is going to be our angle that's the same. Because if it's perpendicular on the right, it's going to be a right angle over here on the left. So in all actuality, it's side, angle, side. So get this written down somewhere. Just because you have a right angle does not automatically we will use HL. Okay, I fixed that. So just because we have right angles does not automatically mean, and again I want to emphasize that, does not automatically mean we're using hypotenuse leg. Okay. However, if you have a right angle and you find yourself writing down a curse word or SSA, the backwards of that, then it's probably going to be a hypotenuse leg. So keep that stuff in mind. All right, that's it for this video. Go ahead and hit the stop button and go ahead and start your practice.